give up, you have to be dead, or completely incapacitated.
Don T. Boom, my son Holio. I don't always attend, but when I do, the meeting agenda is balls. Agenda. Cisco ccna but. Python but. DevOps but. Agronom but. Not a trader but. Universe but. So now Cisco ccna but. Previously on Cisco but. IP protocol header. And now on Ready Not to Die. Internet Control Message Protocol, or in other letters ICMP but. The Internet Control Message Protocol, aka ICMP, enables system on a TCP/IP network to share status and error information. You can use the status information to detect network trouble. ICMP messages are encapsulated within IP datagrams so that they can be routed throughout a network. Two programs that use ICMP message are Ping and Tracer. Ping, aka Packet Internet Network Groper, and Tracer T. You can use Ping to send ICMP echo requests to an IP address and wait for ICMP echo responses. Ping reports the time interval between sending the request and receiving the response. With Ping, you can determine whether a particular IP system on your network is functioning correctly. You can use many different options with Ping utility. But remember that ICMP as the protocol in the TCP/IP protocol suite that is responsible for error and status reporting. Programs such as Ping and Tracer T use ICMP. Tracer T traces the path taken to a particular host. This utility can be useful in troubleshooting internetworks. Tracer T sends ICMP echo requests to an IP address while it increments the TTL field in the IP header by a count of 1, after starting at 1, and then analyzing the ICMP errors that are returned. Each succeeding echo request should get 1 unit further into network before the TTL field reaches 0 and an ICMP time exceeded error message is returned by the router attempting to forward it. Boom boom boom. But now Python but. Python, a tool, not a reptile but. Why Python but why not Python but? Python rivals? Who? Python has 2 direct competitors, with comparable properties and predispositions. Perl, a scripting language originally authored by Larry Wall, and Ruby, a scripting language originally authored by Yukihiro Matsumoto. The former is more traditional and more conservative than Python, and resembles some of the old languages derived from the classical C programming language. In contrast, the latter is more innovative and more full of fresh ideas than Python. Python itself lies somewhere between these 2 creations. The inter is full of forums with infinite discussions on the superiority of one of these 3 over the others should you wish to learn more about each of them. But Python but. Where can we see Python in Cation? We see it every day almost everywhere. It is used extensively to implement complex internet services like search engines, cloud storage and tools, social media and so on. Whenever you use any of these services, you are actually very close to Python, although you would not know it. Many developing tools are implemented in Python. More and more everyday use applications are being written in Python. Lots of scientists have abandoned expensive proprietary tools and switched to Python. Lots of project testers started using Python to carry out repeatable test procedures. The list is long. But Python but. Why not Python but? Despite Python's growing popularity, there are still some niches where Python is absent, or is rarely seen. Low-level programming. If you want to implement an extremely effective driver or graphical engine, you would not use Python. Application for mobile devices. Although this territory is still waiting to be conquered by Python, it will most likely happen someday. Boom boom boom. But now DevOps but. So many buts. Operating system sockets maybe but. Sockets are the strategies that are used for communication between processes. It is mainly used in client-server-based systems. When 2 systems want to communicate with each other, sockets are the endpoint on either of the communications processes. But a pair of process communicating over a network employs a pair of sockets, aka 1 for each process. These banks should employ me. Now, when 2 processes want to communicate, There needs to be a connection between then and at each end of the connection each of these processes will employ a socket each, so a pair of communicating processes over a network will employ a pair of sockets, one for each process. What is this? Repeat town? But how can we identify but in a socket? A socket is identified by an IP address concatenated with a port number. Servers implementing specificity services such as Telnet, FTP, HTTP listen to well-known ports. Exampleo. Telener server is used for remote logging which listens to port 23. FTP aka File Transfer Protocol is used for transferring files, server listens to port 21. Web or HTTP aka Hyper Transfer Protocol server listens to port 80. A port number is going to identify each of the processes, services that are going to be provided. Blah blah. All port below 1024 considered well known. We can use them to implement standard devices. But, how does communication between these processes employing a pair of sockets takes place? Socket but? Server but waits for incoming client request by listening to a specificity port. Once a request is received, the server but accepts a connection from the client but socket to complete the connection. In a client-server systems, clients asks for information from the server and server but provides the information to the client but. In order for the client but to communicate to their server but and the server but to communicate to the client but back, there needs to be a connection between the client but and the server but. Duh. In order to establish this connection, we are going to use sockets but. Damn son. What is this but repeating? Sockets are specifically used for client-server based systems. But now what? Now agronom but. Day 22. OTDR, Optical Time Domain Reflectometer. OUI, Organizationally Unique Identifier. PaaS, Platform as a Service. PAN, Personal Area Network. PAP, Password Authentication Protocol. PAT, Port Address Translation. PC, Personal Computer. PCM, Phase Change Memory. PDoS, Permanent Denial of Service. PDU, Protocol Data Unit. Boom this but boom boom. Now but. Skip the trader stuff but. Universe Comsos but. Cosmological redshift. Laboratory experiments here on Earth have determined that each element in the periodic table emits photons only at certain wavelengths, determined by the excitation state of the atoms. These photons are manifest as either emission or absorption lines in the spectrum of an astronomical object, and by measuring the position of these spectral lines, we can determine which elements are present in the object itself or along the line of sight. However, when astronomers perform this analysis, they note that for most astronomical objects, the observed spectral lines are all shifted to longer, redder, wavelengths. This is known as cosmological redshift or more commonly just redshift. Caused solely by the expansion of the universe, the value of a cosmological redshift indicates the recession velocity of the object, or its distance. For small velocities, much less than the speed of light, cosmological redshift are related to recession velocity. At larger distances, higher redshifts, using theory of general relativity gives a more accurate relation for recession, which can be greater than the speed of light. Note this does not break the ultimate speed limit of c in special relativity as nothing actually moving at that speed, rather the entire distance between the receding object and us is increasing. This is complex formula requiring knowledge of the overall expansion history of the universe to calculate correctly, but a simple recession velocity is given multiplying the common distance of the object by the Hubble parameter at that redshift. But I think I lost you long ago, so boom boom but boom. Bye bye son Holio. Dumbolio? Dump.